Hello, welcome to the Maths Matrix and part 2 in the ratio series. My name's Rebecca and in this video we're going to be doing scaling up ratio. I'm not going to put any questions on screen for you to check your knowledge against because even if you already know how to scale up ratio, there's an alternative method that I'd like to show some of you. It's not something you'll have to worry about unless you're going for one of the higher grades, but sometimes they hide algebraic fractions within ratio questions and you'll only be able to answer them if you know this alternative method. So stay tuned. You'll be needing paper and a pen, and for some of the harder questions you'll probably also need a calculator. I'm going to move you across to the small whiteboard now. Let's get started. Alright. If you took part in part 1 of the ratio series, then just continue with your notes. And if this is the first one that you're watching, then put a title of ratio. And then either way, put a subtitle of scaling up ratio. And then just put e.g. in a garden, the ratio of red roses to pink roses is 5:3. There are 18 pink roses. How many red roses are there? Now, the way we would do this is we would put red to pink, and then the ratio of red to pink was 5:3. So we'd put 5 on red side and 3 on pink side. We were then told that there were 18 pink roses. And what we're being asked is how many red roses go there. This is just like scaling up fractions, except it's done sideways. So to get from 3 to 18, we've multiplied by 6. And therefore, to keep the ratio the same, we need to times that by 6 as well. So there would be 30 red roses, and that would be the answer. I'm going to show you now how to answer that same question using the old-fashioned algebraic method. This is probably not something you need to worry about unless you're going for a level 7+ or maybe a 6+. So have a look at it, but if you don't understand it and you're not going for one of the higher levels, then don't worry about trying to replicate it. If you are going for one of the higher levels, just put in your notes, alternate solution, algebraic method. Now, like before, the ratio of red to pink will be 3:5. And we were told that there were going to be 18 pink roses. 3 was on the right hand side, so we'll fill in on the same line and equals, and we'll put an 18 on the right hand side to correspond to pink. And where red would go, we're going to put an X. What we would then do is we would set up X over 18 because it makes our working out easier if we lead always with the X. So we'll just start with the X, and the bit that went with the X we'll put under it, and then we'll put 5/3. And the reason I'm putting 5/3 and not 3/5 is because X is on the left and 5 is on the left. So because X is on top there, the left-hand side also has to be on top there, and so the right-hand sides have to be on the bottom. We would then solve this using algebraic methods. If you don't know at the moment how that would be solved to get to X equals number as your answer, then don't worry about it at this stage because I am going to cover algebra in a lot of detail at a later date. However, for those of you who do know and who can follow it, To undo a fraction, we times out by a denominator. So we'd then have x equals 90 over 3, which would give us the same 30 red roses that we had before. So the answer doesn't change, but the way that we get our answer is slightly different. I'll show you another one now using both methods. So if you put e.g. at a football match, the ratio of women to men is 4 to 7. There are 2,000 women. How many men? So for this one, we would put women to men, and then the ratio was 4 to 7. And then there were 2,000 women, so we put 2,000 on the woman's side, and it's this bit here that we're being asked about. To get from 4 to 2,000, we times by 500. If you couldn't immediately see that, then you could, on a calculator paper, put 2,000 divided by 4, or on a non-calculator paper, do 2,000 divided by 4 that way to give you the answer of 500, which would then tell you that you need to times 4 by 500 to get to 2,000, okay? Because we've times by 500 on one side, to keep things in balance, we have to times by 500 on the other side as well, to give us an answer of 3,500 men. I'll now show you the algebraic way. So if you're going for one of the higher levels, put alternate solution, algebraic method. Now for the algebraic method, we'd still set up women and men in the ratio 4 to 7. And then this time we'd put equals 2,000 to x, because women are on the left and we would know how many women are at the match. Men are on the right and we don't know how many men are at the match. We would then lead with our x and put x over the thing that it belongs with, the 2,000, equals x is on the right, so put the right hand side on top there, over 4. And then we would undo that fraction by multiplying both sides by 2,000 to give us x equals 14,000 over 4, which would give us the same answer of 3,500 that we had when we did it using the other method. I'll show you one involving 3 parts. So if you put e.g. in a garden, the ratio of tulips to bluebells to daffodils is 2 to 3 to 8. There are 28 tulips. How many bluebells and daffodils? So we would put tulips, bluebells and daffodils, and 2 to 3 to 8. And then there were 28 tulips. To get from 2 to 28, we times by 14. So we need to times 3 by 14 as well, which is 42. And we need to times 8 by 14. Now, I don't know what that is in my head, so in an exam situation on a non-calculator paper, you'd have to work that off to one side using long multiplication. So 8 fours are 32, 8 ones are 8, 9, 10, 11. So there'll be 112 daffodils. So in your answer, you'd put 42 bluebells, 112 daffodils. And in your working out, it's quite okay to leave these lines in place so that the examiner can see what you've done. So you can use that as a way of showing what you've actually done. And in the answer spaces, that's what you'd put. Okay? I'll do the same question again now, but this time using the algebraic method. So if you're going for one of the higher levels, just put alternate solution, algebraic method. We would still put tulips, bluebells and daffodils, and we would still put 2 to 3 to 8. Now this time we're going to have to take it in 2 separate parts. So we're going to have 28 for the tulips and X for the bluebells and Y for the daffodils. What I'll then have to do is do one part at a time. So dealing with the X first, I'm going to put X over 28 using these parts equals X is in the middle, so I pick the middle one, and 28 was on the left, so I pick the left one. So that's going to make the working out for the bluebells. I'll then do the daffodils separately, so I'll put Y over 28 for the daffodils, taking that, and I'll put 8 and 2. So I've had to make 2 separate solutions for 2 separate unknown parts. Then it would be just like before. I'd times by 28 there and there. Don't know what 28 times 3 is, so I'm just going to pop it in the calculator. So X would equal 84 over 2, which would give me an answer of 42 for the bluebells, same as before. I would times by 28 there to give me Y equals 28 times 8 is 224 over 2, which would give me the same 112 daffodils that I had before. So of course I get the same solutions but using different methods. I actually think you're very unlikely to get a 3-part ratio in algebra. So if you only want to use the algebra method for 2-part ratios, that's absolutely fine. Sometimes the numbers might not be as nice, but the method doesn't change. So we'll do one more. Just put, e.g., a rectangle has its long side and short side in the ratio 9 to 5. The long side is 31.5 centimetres. How long is the short side? So we would put long to short, 9 to 5, and then the long side was 31.5, and we're being asked what's the short side. Now it's not immediately obvious how you get from there to there. On a non-calculator paper, we'd have to set it up as a divide off to one side to find out. So in asking what do we times by to get from 9 to 31.5, what we're really saying is how many 9s in 31.5, in other words, a divide. 9s into 3 doesn't go. 9s into 31 goes 3 times, remainder 4, and 9s into 45 go 5 times. So we're timesing by 3.5. On a calculator paper, you could just put 31.5 divided by 9. That means I've got to times by 3.5 there. So on a non-calculator paper, I'd be doing 3.5 times by 5. Or if you wanted to do 35 times 5 and then put the decimal point in at the end, that would be fine as well. 5 5s are 25, 5 3s are 15, 16, 17. So I'd have 17.5 as the answer for the short side. All right. Same question again using the algebraic method. Long to short, 9 to 5 equals 31.5 to x. X is what we're trying to find and it's partnered up with 31.5. X is on the right, so 5 goes on top over 9. So right hand side's on top, left hand side's underneath in this case. And then again, like before, we'd be timesing out by 31.5 to give x equals 31.5 times 5, 157.5 over 9, which gives us the same 17.5 as before. All right. Most of the time when you're scaling up a ratio, you will use that method because most of the time it's the quickest and easiest way. The only reason that I'm telling you about the algebraic method, the more old-fashioned method, is because sometimes they give you a ratio that involves algebra. It's very rare, but they did it last year for the first time in a long time. And they got given a question. I'm not going to tell it you exactly because some of you will be coming across it in mocks at some stage. But it was something like 2x plus 5 to 5x minus 3 equals 2 to 3. Find x. The question said something like that. If you only knew the scaling up method, that method of scaling up ratio, there was no way that you could access the question. This question relied on you using the old-fashioned algebraic method. And what you had to do in order to find x was you had to set up 2x plus 5 over 5x minus 3 equal 2 over 3. So that over that equaled that over that. You could just as easily have put 5x minus 3 over 2x plus 5 equals 3 over 2. So it didn't actually matter which bits went on top and which bits went underneath, as long as if you used left on top for one of them, you put left on top for the other, or if you used right on top for one of them, you put right on top for the other. And then the question was algebraic fractions, so it would have been a case of timesing out by denominators and solving to find x. But if you didn't know that way of using fractions and rearranging by timesing out the denominators, there was just no way that you could access the question, and it was worth 4 marks, which was quite a lot of marks to give away. It was right near the back of a paper, which is why I've said only worry about this method if you're going for a level 7+. But if you are going for one of the higher levels and you are quite confident in your algebra work, or you're hoping to get quite confident in your algebra work, then it's as well to know that ratios can also be solved by setting up 2 fractions and making them equal to each other. If you want to use the algebraic method as the only way of scaling up ratio, that's absolutely fine. You don't have to learn two separate methods. You don't have to learn the easy timesy one and the setting up fractions one. You can just use the setting up fractions one if you want to. When I was at school, we were only taught the setting up fractions way. I only thought of doing it that way much later, actually. So you don't have to learn both methods. You can just go with the algebra one if you are going for one of the higher levels, and just stick with that if you want to. But if you want to learn both, then that's fine. And if you're not going for one of the higher levels, then don't worry about the algebra one. Just stick with this one, okay? I'm going to pop some questions on screen now, and hopefully you'll be able to do them. It is possible to do them all without a calculator, so do try. But if you need a calculator, then no problem, use one. I'll pop the solutions up afterwards so that you'll be able to check if you got them right. Thank you very much for watching, and I will see you in part 3, where we will be doing dividing in a given ratio.